This is Mr. Anderson for Kellogg Community College. We're going to be taking a look at doing some manipulations to the amplitude and the cycle of tangent and cotangent on this part 2 of chapter 2 section 5 video for trigonometry. Now, the first thing we're going to do is we will graph each of these functions and label at least 5 key points of 2 cycles, and we're going to also use the graph to determine the domain and range of each function. Now I'm going to set up some parameters here. The first thing I want to do is I want to write down the parent function of each of these here. And what I will do is take this out to 2 pi. So 2 pi is going to be over here. And I'm going to look and see that this is going to be pi here in the middle. And so this will be pi over 2, and this will be a quarter pi right there, or sorry, pi over 4. And I want to talk to you about the asymptote lines first of all. The tangent asymptote lines, as described on the first video that I had here, are going to be at pi over 2. So the line x equals pi over 2 is one of my asymptote lines, and that will occur here, and also it will occur here. The actual line for tangent is going to start here at the origin at 0, 0 and go up from here. I will change my points. This is going to be 1 and -1 here. This is -2. This is going to be +2 here. Okay, so what this gives us here, this gives us a solid point at pi over 4, comma 1 there. This is the line x equals pi over 2. Then starting here, we're going to have a point at -1 on my y at 3 pi over 4. Since this was 2 pi over 4, this would be 3 pi over 4. 4 pi over 4, or pi, is going to be at 0. Then 5 pi over 4 is going to be right there at 1. And then over here at 6 pi over 4, or x equals 3 pi over 2, there's another asymptote line. Then there's going to be another point here at our 7 pi over 4, and at 8 pi over 4, or 2 pi, that's going to be another x-intercept. Now, what we have here is going to be, for our next function, we're going to write in the y equals -2 tangent of x, which is going to change things around a little bit. Let's first of all put my, I'm going to put -2 in here in the middle. And though the graph is going to look just slightly different, I like to use my calculator when I show the difference between these two graphs here. So what this does, I'm going to keep my asymptote lines in the same place, like so, right there, and also right there. This is going to be at pi. Now, what's interesting about this is that this is a -2, so that means my line is going to go down like so. And at that point right there, this is going to be pi over 4, comma -2, and get infinitely close to x equals pi over 2, but never quite touch it. All right, now the graph is also going to swoop like so and intersect at this point and this point. So this is the point, let's see, this is going to be pi over 4, 2 pi over 4, this is 3 pi over 4, comma 2, 4 pi over 4, comma 0, or just pi, comma 0, and this is going to be 5 pi over 4, comma -2, right there. And this is y equals 6 pi over 2, or 3 pi, or 6 pi over 4, which is 3 pi over 2. And then up here, this graph will come from the top to 7 pi over 4, comma 2, and then 8 pi over 4, which is the same thing as 2 pi. So there is our tangent graph. Now let's go look at the cotangent graph. I'm going to move this down a little bit. Oh, shoot. One of the things I forgot is to talk about the domain and range of the function. Now let's go back. I'm going to put in the asymptote lines because that's really what we need to talk about domain and range. So if we just focus on the asymptote lines, which occurred at every single pi over 2. And this is going to be 3 pi over 2. This is 5 pi over 2. And then finally 7 pi over 2, like so. So these were the asymptote lines. The asymptote lines of tangent are pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2. So when we talk about the domain, what is that then? Well, it's going to be the set of all x values where x is not equal to k times pi over 2, where k is an odd integer. Now, integers are positive or negative whole numbers and can include 0 as well. So k is an odd integer, so you can see that 1 pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2. The domain can be everything except those values where k is going to be an odd integer. Now, the range of the function is going to be all real numbers. So the range is all real numbers because you have these lines that at this stage of the game we're going like this, so you could have infinitely big y values with no exceptions in any of these places right there. All right, cool. Now let's keep going on from here. I know that this probably wasn't quite marked out where things were on the previous graph, but it gives you that idea that each of these, again, each of these asymptote lines is a disconnection in the domain. All right, so let's go and look at the next problem. This is 3 cotangent of x, and what we're going to do first is we are going to put up the parent function, y equals cotangent x. Now here we have a asymptote line at pi, like that, and also an asymptote line at 2 pi. So what this gives us here, this gives us some pretty points at these 3 locations. This is going to be 1, this is going to be -1, and that's the 0. And the cotangent is going to come swoop like this, and this is going to be at pi over 4. This is going to be at pi over 2. This is going to be at 3 pi over 4, and repeat itself again like so. And kind of swoop in and then turn like that. Now with the -3 we change things a little bit. So now we're going to go between 3 and -3, and also you see that the direction is going to change as well because we have a -3 in front of our problem there. So our amplitude, philosophically these amplitudes actually do not exist for these functions, but what they do is they do change the speed at which they accelerate to infinity and -infinity depending on your perspective of how the line's moving. So this here is going to be pi over 4 comma -3, and this over here is going to be 3 pi over 4 comma 3, because this is each an interval of pi. This right here is going to be pi over 2 comma 0. Then let's see, if you count by fourths, this is 1 pi over 4, 2 pi over 4, 3 pi over 4, the 4 pi over 4, this is the asymptote line of x equals pi. Then we get 5 pi over 4 comma -3, 6 pi over 4 or 3 pi over 2 comma 0, and then 7 pi over 4 comma 3. Okay, so what we have there is we have all of our points graphed and labeled, and before I erase this now, let's talk about domain and range. The domain, you can see that there is an asymptote line at 2 pi, x equals 2 pi, x equals pi, x equals 0 pi. So the domain is going to be the x values, where x cannot be any value of k pi, where k is an integer. So as long as k is a positive or negative whole number or 0, k is not going to work in this case. So that's the domain, and the range is real, and I'll use some interval notation for this, negative infinity to positive infinity. So there's some set notation for the domain and some interval notation for the range. All right, let's move on to the next problem, problem 3. And we'll stop this video after problem 4 here, because what we're about to do is we're going to write the parent function down again quickly for tangent. And the tangent function is going to be, oh, what happened there? Figure out what made that sound. All right, so let's figure out the tangent function here. The tangent is going to be, again, at every pi over 2. So if this is pi and this is 2 pi, pi over 2 is going to be an asymptote line. So here's our parent function for tangent, like so. And again, let me put my dots in here for 1 and -1, making these like some other number. All right, so we're going to have a little bit of a curve like that. Sorry for my penmanship. And then this curve is going to be like so. All right, so now we have a situation where we have an omega. And this omega is going to be 1/2. So omega is 1/2, and we have to find our period. So we're going to take our cycle, which is 2 pi, and divide it by 1/2. But 2 pi divided by 1/2 is the same thing as 2 pi times 2. So we're going to be moving half as fast, so one cycle will be completed by 4 pi. Now, instead of stretching this out, what I'm going to do is use the same picture, but my technique that I enjoy doing to show both cycles on the same piece of graph paper is to copy the picture, but let the points do the talking. And these points at these locations here, these points will, sorry about that, I'm really trying to make my penmanship better. These points will actually tell you where you're supposed to go. And one of the quick ways to do that is to take my omega and multiply by my first interval here. See, in this previous graph, this was pi over 4. Now what I'm going to do is take my pi over 4 and divide that by my omega. If I divide it by my omega, instead of dividing by a half, I'm going to multiply by 2 over 1. This gives me pi over 2. So now this location is pi over 2 comma 1. Right there. That's pi over 2 comma 1. This is x equals pi. That's the asymptote line. Then this is, again, we're traveling in half units here, so this is pi over 2, 2 pi over 2, 3 pi over 2 comma -1, 4 pi over 2, this is 2 pi, and then 5 pi over 2 is here, comma 1. 6 pi over 2, this is x equals, this is going to be x equals 3 pi here, so this is pi, 2 pi, 3 pi, and then this would be, this is again 6 pi over 2, so this would be 7, this dot here would be 7 pi over 2 comma -1, and this would be 8 pi over 2 comma 0, or 4 pi comma 0. So what this is showing me is that when I talk about my domain and range, these x equals equations are very important to me. So this is going to be x, the domain is going to be x where x is not equal to k times pi, where k is an odd, where k can be any, we don't want that to be any integer. Or any, in this case, any odd integer, because it's going to be 1, 3, 5, 7, 9. So cannot be equal k, where k is an odd integer. There we go. Now, of course, the range. I'm not going to use, I'm going to use interval notation for the range. The range is going to be also all real numbers from -infinity to positive infinity. All right, one more problem to go to wrap up this little video here. Let's go to the last picture here, which is going to be cotangent. All right, so let's get it rocked out here. So again, I'm going to write my parent function of cotangent of x. That's going to be my parent there. The intercepts for this, or sorry, the asymptote lines are going to be at every pi there. So this is pi and 2 pi. And so what we have here are our points at 1 and -1. These are our important spots right there. Let's go down this way, and then it takes a turn. Sorry about my penmanship there. All right, and we'll, whoops, there we go. And take a turn there. Okay, so it kind of like swoops in and turns on that dot there at pi over 2 and 3 pi over 2. Okay, so now what we're going to do is again take a look at our period or cycle, which is going to be 2 pi divided by omega. And my 2 pi divided by my omega, I don't want to divide by pi over 4, I want to multiply by 4 over pi. So divide both sides by pi. So we're going to go this in 8. We're going to make a complete cycle in 8. Now what I'm going to do, again, is to copy the picture and let the points do the talking. So there are the points here. We come from the top, we turn directions, and we go down like this. Hey, that's the best one I've done so far. Let me keep working on this here. Okay, so come on down and take a turn there. Okay, so what I'm going to do is take my first interval, which over here was pi over 4. Take my pi over 4 and divide by my omega, which in this case is going to be multiplying by 4 over pi, which is, holy moly, look at the 4's simplify, the pi's simplify. So this is going to be 1. This is going to be 2, and this is going to be 3. And then we have an asymptote line at x equals 4. And this would be 5 and 6 and 7, and this is going to be x equals 8. Wow, some nice asymptote lines there. And what this gives me too, it gives me some easy points to go from here and here, because this is positive 1, sorry, and this is -1. So 1 comma 1, 2 comma 0. I like it sometimes when we have these nice numbers without pi's in them. But now we get to talk about domain and range. So to finish up this ditto, or this part 2 of this 4-part video, is that the domain is going to be the x values, where x cannot be equal to 4k, where k is an integer. What that means is that, 4, 8, 12, 16, and also into the negatives, including 0, these are all problems for the domain because they are asymptote lines, including 0. 0 is an asymptote line. So our range is going to be all real. So that's our range right there. And that will solve that. All right, so we're going to get into 2 more videos after this for this section. I thank you for watching. And again, if you have any questions, please email.